Okay, this video is going over a class review that we did to get ready for the conics test. So it's going to go over the different types of conics and graphs that we have. So on the first one, this is a circle. We know it's asking for the center and the radius. And so to get it into standard form, we're going to have to complete the square. So we're going to group the x's. So we have x squared plus 6x plus blank. Then group the y's plus y squared minus 8y plus blank equals. And the 16 is going to go to the other side, so it becomes negative 16. Now we need to fill in the blanks. Half of 6 is 3, 3 squared is 9. So to keep it balanced, I'll put 9 over there. Half of 8 is 4, 4 squared is 16. And to keep it balanced, I'll put 16 over there. So now I can rewrite it. So I'm going to factor this first part, and that's going to factor to x plus 3 squared plus, and then I'm going to factor the second part. And that is going to factor to y minus 4 squared equals, and then I'm going to add these numbers at the end. The 16s cancel, so that just leaves me with 9. So that means my center is negative 3, 4, and my radius is the square root of 9, which is 3. So negative 3, 4 is here, and then you're just going to go 3 points in each direction, and there is your circle. Okay, now number 2 cannot be a circle, it can't even be a hyperbola or ellipse because it just has an x, it doesn't have an x squared. It's only got one of the variables squared, which is y. So we need to write this parabola in vertex form and then graph it. So to do that, we have to complete the square. So I have to take out, when I complete the square, I have to have a leading coefficient of the invisible positive 1, and right now I don't, so I'm going to take out a negative 4. So that leaves me with positive y squared. Now I'm taking positive 24 and divided by negative 4. So that's going to be negative 6y plus blank minus 30 plus blank. So in the blank, half of 6 is 3, 3 squared is 9, but it's a trick. I didn't add 9. I added negative 4 times 9, which is negative 36. So at the end, I do the opposite of that, which is positive 36. So now when I write my equation, I'm going to have x equals, I've got my negative 4 here, and then I need to factor this part, which is y minus 3 squared, plus, and now I'm going to add the numbers at the end, which would be 6. So now, because it's x equals a negative, I know it has to open left. The vertex, because there's y in the parentheses, I know that controls the y, so it's positive 3, but this one is 6. So now I'm going to graph my point, so I have the point 6, 3. Okay, when I go to graph it though, I'm going to go up and down 1 and to the left 1, but because of the 4, I have to go up and down 1 and left 1, 2, 3, 4. And then instead of going 4, I'd have to go 16, which I don't have enough room for. So it would be like that. The axis of symmetry, if I plotted this to the wrong spot. There we go. The axis of symmetry, if you draw it through, notice it crosses the y-axis at 3, so it's y equals 3. All right, on the next one, now we have a parabola. We know it's a parabola because we're asking for the axis of symmetry. It's y equals a positive, so we know it's going to open up. The vertex, because there's an x in here, it's the opposite of that, so it's going to be negative 6, 7. So when I graph it, I'm going to go to negative 6, 7, which is right here. Now, instead of going over 1 and up 1, I'm going to go over 1 and up a half, and then over 2 instead of up 4, I'm going to go up 2. So my graph looks like this. My axis of symmetry is right here. It's a vertical line. It crosses the x, so it's going to be x equals negative 7. Oops, forgot my negative over there. The domain left to right, it keeps getting wider, so it's all real numbers. My range, I go from the bottom up, it starts at negative 7, and it continues on to infinity. Okay, this one, we've got another parabola. We know it's a parabola because we only have a y squared. Look at now fast on number 4. See how it's an x squared and a y squared? That can't be a parabola. A parabola just has one of them squared. Okay, this is x equals a positive, so we know it's going to open right. This has got a y in the parentheses, so that's going to control my y. It's positive 3. My x is negative 5. So I'm going to go negative 5, negative 3. And I'm going to open right. So up and down 1 and right 1. Up and down 2 and right 4. And there is my parabola. The axis of symmetry cuts it in half. It crosses the y-axis at 3. So it's y equals 3. The domain is left to right. And on the left, it starts right here at negative 5. And it continues to the right. The range, though, is all real numbers because it keeps getting wider up and down. Okay, number 4. Because it's got a minus in between, this is asking excuse me, for the asymptotes, we know it's got to be a hyperbola. My center is the opposite of what's in the parentheses. So 3, negative 2. The slope of my asymptote is the opposite, or plus or minus b over a. Well, this is b squared, the 16, so b would just be 4. This is a squared, so a would just be 3, so it's plus or minus 4/3. So I'm going to start at the center, 3, negative 2. And then my rise is 4. So I'm going to go up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. My run is 3. So I'm going to go right and left 3. And then create the box. Okay. Now I can connect the corners and draw in the asymptotes right there. Now I need to figure out which way it opens. Well, if I look at the end, because it's a positive one, that means that it's going to be a horizontal hyperbola, which means it's going to open right and left. So I've got one arc here and a one arc here. The vertices are these right and left points, the 2 points that the parabola touches. So this first point is going to be 0, negative 2. Whoops. And this point over here is going to be 6, negative 2. The domain, as we read it from left to right, well, it starts at the left at negative infinity, it keeps going until it gets right here at 0. And then it stops, but it picks back up again at 6, and it goes on to infinity. The range is up and down, so it goes negative infinity to infinity. Okay, number 5. Because it's got a minus sign, and because it equals a negative 1, the only one that can happen to is a hyperbola, and it's also asking me for the asymptote, so it's got to be a hyperbola. All right, this one, the center is going to be negative 1, 0. Also, because the numbers are the same underneath, it can't be an ellipse, because if the numbers were the same underneath for an ellipse, it'd become a circle. So my slope or of asymptote would be plus or minus b over a. So that's plus or minus 5 over 5. This is one of the only times we don't want to reduce anything. So here's my center. So I'm going to go 5 in each direction. Okay, and then create the box by extending the lines. Then draw in the diagonals for the asymptotes. Now this one, because it equals a negative, we know that it is a vertical hyperbola, which means it starts on the top and on the bottom. So my vertices are the top and bottom points. So I've got one at negative 1, 5. Oh, blank. Negative 1, 5 and negative 1, negative 5. The domain left to right keeps getting wider, so it's negative infinity to infinity. The range, however, it starts down low at negative infinity, and then it goes up to negative 5 and stops, and then it starts again at positive 5 and goes to infinity. Okay, this one right here, this has got a plus sign, and it equals a 1. When it's plus sign and it always equals a positive 1, then it has to be an ellipse. The center is the opposite of what's in the parentheses, so we have negative 2, 6. So we go to negative 2, 6. Okay, then the vertices and co-vertices, well, we got a graph to find them. Because under the x is a 36, we know we're going to move left and right the square root of that, which would be 6. It's just one past. And now we have to find the y. So we're going to go up and down the square root of 9, which is 3. That's 2 past. And then we can connect our points. The vertices are on the longer asymptote, so they're the left and right. So this one, well, if this is 7, one more would be 8. So it would be -8, 6. Oops, I did an infinity sign. -8, 6. And this one is going to be 4, 6. And that was the vertices on the longer axis. And then the co-vertices are on the smaller axis. So we've got -2, 4. And then -2, this goes 2 spaces. So if this is 7, that's got to be 8. So this is 9. Hold on. Well, hold on, friends. See if we can make it work. Well, I'm trying. There we go. There we go. -2, 9. We haven't done domain and range of these, but we definitely can. Domain is the left value to the right value. So it starts, what do we say? At 1 over, which would be -8. And there's a point there, so it's going to be a bracket. So we go from why can I do an 8? We go from -8 all the way to the right, which is 4. The range is bottom to top, so it starts at 4 and it goes up to, what do we say this was? 7, 8, 9. And we're done. All right, one more ellipse. So on this one, the center is going to be 3, -8. So we'll go to 3, -8. Oh, this is not good. We're going to fake this a little bit. Okay. Under the x is a 36. Okay. You know what? I'm making an executive decision. We're going to change this so that it fits better. Let's make this a 2. And let's make this 16. Okay, take 2. So this point is center is going to be 3, -2. And now we can graph that 3, -2. That's more manageable. Under the x is a 16, so the square root of that is 4. So we're going to right 4 and left 4. Under the y plus 2, there's nothing, but there has to be something. So there's an invisible 1. Square root of 1 is 1. So we're going to go up and down 1. And there is our ellipse. So the vertices are the left and right because they're on the longer one. So -1, -2. And over here we have 7, -2. The co-vertices are on the shorter axis, so the top and bottom, so 3, -1 and 3, -3. The domain left to right goes from -1 all the way to 7. And the range bottom to top goes from -3 to -1. That's it. Okay, sorry for the blip in the middle, but we got the video done.